So good evening, friends. Today we will be commencing our next chapter, which is going to come under the database design. It is going to talk about the basics of functional dependencies and normalization for relational database management systems. So normalization is a very important concept. Every student should be knowing it. Normalization is a process where we are going to fine tune your database, optimize your database so that it functions very well. So whenever we design a database, if you have to claim that your database is sound, you should have normalized your database. If you have not subjected to normalization of your database, then obviously your database design is treated as a poor design. So this is very important concept. Please concentrate properly. Please listen to my explanation and try to gain the knowledge out of the class. So here in this particular chapter, we're going to first talk about certain design guidelines. We call them as informal design guidelines for any relational database management system. These design guidelines are to be followed by every database designer to make his database sound. So what are the guidelines that are going to be covered in this particular chapter? You can see on the screen. Totally 4 guidelines we are going to understand, and these guidelines we are going to follow while we are going to design our database management systems. The very first guideline is making sure that the semantics of the attributes is clear in the schema. This is as simple as this. Whenever you are going to design a schema, nothing but a table. In simple words, I can say, if you are creating a student table in your database, definitely what are the attributes that you want to add to that particular table, they should be meaningful and they should have a common theme. So for a particular student, for a typical student, we expect his roll number or university seat number to be added, his name, his date of birth, maybe his gender, the branch in which he is studying, the year in which he is studying, maybe the semester, and in addition to that, you may have his academic details, something like his marks and subjects, or maybe his CGPA or percentage, whatever it may be. So, what are the attributes I've spoken till now? They are all meaningful when you consider an entity called student. So, the very first informal design guideline is going to tell you that you have to ensure the proper meaning of the attributes which you are going to consider in your schema. So you cannot put irrelevant attributes in a table and claim that my table is sound. If you want to claim that your table is sound, the very first property is the semantics of the attributes which you are going to use in the table. They should have a common theme. They should be relevant to the context. You cannot club multiple attributes from different contexts, and you cannot group and create a table as you wish. So this is the first guideline. The second guideline is to reduce the redundant information in the tuples. Whenever you are going to add some records to a table, make sure that the records that you are going to add to your table should not lead to redundant information. Redundant information means duplication of information. The information should not be repeated many times in your particular table. So this is called reducing the redundant information in the tuples. And then the third design guideline is to reduce the null values in the tuples. This is very important property. This has to be preserved while designing your schema. You have to eliminate the null values as much as possible. If null values are required to be used, you can use it. There is no rule that we are not supposed to use null values, but try to avoid having null values for the attributes in any of the tuples. And the fourth informal design guideline is disallowing the possibility of generating spurious tuples. Spurious tuples is an idea which you will understand if you take up an example. Spurious tables are nothing but the tuples which are not required for us. They are irrelevant tuples. So we will take up an example for this particular design guideline and understand what are spurious tuples and what is the context that is going to generate these spurious tuples. So these are the 4 informal design guidelines every one of us should understand before getting into the next topic called functional dependency. So if you look into this particular topic, the very first design guideline, which is going to talk about imparting clear semantics to attributes in the relationship. Semantics, just now I told you, it is nothing but the meaning. For example, if you look into this particular company relational database schema, you have here employee. So if you consider the employee relation, the employee relation is made up of several attributes. What are the attributes? Employee name, social security number, which is the primary key, birth date, address, and department number. And you can understand here the department number is the foreign key. So the semantics are very clear in this table because all the attributes what we have considered here, they are all meaningful attributes and they relate to a particular employee. And in addition to these attributes, we have included one irrelevant attribute called department number. You can ask me, sir, employee is a person. Why this department number attribute should come in this particular table? This particular department number is required here because an employee will be working for a department. We need to have a reference from the employee table to the department table by using the concept of foreign key. So for the sake of having a reference from one table to other table, we may include foreign key in our particular relation. So in this particular employee relation, what is the foreign key? Department number. Other than this foreign key, if you see any other attributes in this particular schema, all attributes are meaningful attributes. Employee name, social security number, birth date, and address. These are all having a proper semantics. You know very well why you have included these particular attributes in this particular employee table. Similarly, for department table, we have got a department name, department number, and department manager social security number, which is the foreign key. So like this, in your company database, you have got different schemas, and each schema is having a certain attributes whose semantics or meanings are known to us very clearly. So this is a simplified relational database schema for your company database. It is not the actual schema diagram which we have drawn in the earlier diagrams. It is a simplified version of your company relational database. So this is the way you have to ensure a proper meaning for every attribute that you consider in each relationship. Now we move on to the next example. Here you can see for what are the relations that we have seen here. For these relations, we have drawn one state diagram where we have got a set of tuples added for each and every relation. For employee table, there are certain records. For department location, we have got some as an example, the state information of all the relations: employee, department location, works on, and project. This particular thing can be used as a reference for you when you are going to understand certain concepts on this particular company database. Now, we finally conclude this particular first design principle with a guideline. This is important. Everyone should remember this because there is a possible question in examination. What are the informal design guidelines? Explain them with an example. So this is the first guideline. The first guideline is to design a relational schema so that it is easy to explain its meaning. And very importantly, you have to understand this line: do not combine attributes from multiple entity types and relationship types into a single relation. So this point already we have discussed in the class, in the earlier classes. We are not supposed to bring attributes from different tables and mix them in a particular single table. So obviously we have to separate the tables based on the theme. So I need to have a relation called student. I need to have a separate relation called faculty. I need to have a relation called a department. If it is a college database, if it is a company database, employee is one entity, works on is one entity, department is one entity, project is one entity. So we need to differentiate the attributes. We need to group the attributes into different heads. So that way you need to do. So the first design principles, what it says is design a relational schema so that it is easy to explain its meaning. So this is a simple design principle that we have been following all these days. Now we will take one example, an example where this particular guideline is violated. If you just check here, if you check these particular examples, what you can see on the screen, you can see one schema called EMP-DEPT. In earlier, we have got employee table separately, department table separately. Some of our friends, what he has done is, he wanted to join the attributes of employee table and department table, mix up both and create one more table called employee department. Here, employee department is a new relation that is being created, which is having attributes from two different tables. So what are the attributes? Employee name, social security number, birthday and address are from employee table. Department number, department name and manager SSN are from department table. So the attributes from two different tables are being joined here and a new relation is being created. This is not encouraged. Why this is not encouraged? Because it is a violation of our first informal guideline. We need to have proper semantics whenever we are going to create our table. So two different contexts are being clubbed here. So if you see this employee project relation also, employee table attributes and project table attributes are mixed up and one new table is being created called employee project table. So this is also a bad combination of attributes where we are trying to group them. And we will understand what are the problems if you group attributes from two different tables into a new table. I will explain those problems at a later stage. Right now, you please understand that these two schemas, new schemas that are being created, they violate the first informal design guideline. So now we move on to the second informal guideline. So what is the second informal guideline? So this is going to say that redundant information in the tuples and update anomalies are to be avoided. That means whenever you are going to create tables, make sure that redundant information will not be stored in that table. So is there any possibility of having redundant information in a table? Definitely yes. If you see an example here, if you see, this is a new table that is created, which is a combination of employee table and department table. So if you see in this particular table, it is being clearly marked where and all redundancy is there. You see here last two columns, department name, department manager, social security number. Is it not that the research department is repeated 4 times? Is it not that the administration is repeated 3 times? Is it not that a particular manager is being repeated several times? Yes, definitely. Why this repetition has come? Because as we have joined both employee table and department table and we have grouped the attributes and we created a new table, the drawback here is when you are going to try adding employees to this particular table, there may be a possibility that multiple employees may work for the same department. So the department name will be repeated. And similarly, multiple departments working for multiple employees working for a department will be managed by a single manager. So even department manager social security number will also get repeated. Suppose in a department called research, there are 30 employees. So for all the 30 employee tuples, for every employee, the department name and the department number and the manager SSN remains the same. So it is a redundant information which has to be avoided. So, but this we have avoided in our database design. When we have created tables in our laboratory, we have never grouped, we have never created a table which is having a combination of attributes from two different tables. We maintain separately employee table, we maintain separately department table. Wherever we require a relationship, we used to relate one table to other table by using the foreign key concept. Using referential integrity constraint, we used to join the contents of one table to other table. There is no concept called redundancy. There is no duplication of values in the tuples. Because in the department table, for each department, there will be only one entry. If n employees are working for the same department, I have an option of relating all these employees to a single department. So the department name need not be repeated. The manager SSN need not be repeated. There will be only one entry for that particular department name for which all the employees are working. But if you simply create a complex table like this by adding attributes from two different tables, this redundancy is the biggest problem. This is the problem you need to notice. Similarly, for the employee project table, there is a redundancy with respect to employee name and project name and project location. Why there is a redundancy in employee name? Because one employee can work on more than one project. So his name should be repeated every time a new project is being added on his name. Similarly, and a single project, multiple employees will be working. For all the employees working on a single project, the project name and project location, obviously they are going to get repeated. So if you see here, the project name called product X is repeated twice and product Y is repeated thrice. Product Z is repeated twice. Similarly, project locations are also repeated accordingly because on a single project, multiple employees can work. So this is called redundancy. The second design, informal design guideline says that avoid this kind of redundancy. So to avoid this kind of redundancy, we should avoid creating tables of this sort. where we combine attributes from two different tables. And if you create a new table like this, always there is a chance for redundancy. Try to avoid this redundancy. And also this particular guideline says that not only you have to take care of redundant information in the tuples, but also you have to take care of update anomalies. So what are anomalies? Anomalies are the flaws, are nothing but the error conditions that are going to encounter when you try updating your database. So we will see certain examples which are going to demonstrate this particular update anomaly. So I will just to show you this anomalies. Someone wants to insert a new tuple into your table. For example, into the employee department table, we want to insert a new employee. But once an employee has joined the organization newly, immediately he will not be assigned any department. Then he will not, as he is not being currently allocated to any particular department, what is the value that are going to give for the department on which he is working? Right now, no department is being allotted for the employee. The department name should be null. That is the only possibility. This is an anomaly. You are not having a value, but you are forcibly asked to give the value for the department. Right now, for the employee, department is not being fixed. So the only possibility is you have to put the department name or department number to be null for that particular employee. Similarly, whenever you are going to insert a new department that has no employees. So assume that in a company today, their policy has changed. They have introduced a new department. Right now, no employees are being appointed in that department. Department is existing, but no recruitment has occurred. No people have joined that particular department. When you want to insert a new department into this particular table, what values you will give for the employees? Right now, there are no employees. But I cannot only just add the department details, because it is not only department, it is also holding employee information, because the table name itself says that employee department. That means you have to insert an employee working for the department. Right now, there are no employees working for the department. Then what value you will put for the employees? Definitely have to put null. So this is called insertion anomaly. And we will see the anomaly, one more anomaly called deletion anomaly. So when this deletion anomaly is going to occur, suppose if you want to delete, from a particular, if you want to delete a particular employee tuple from this particular table, and assume that he is the last employee of that particular department getting deleted. Assume that there is a department called ABC. In that right now there is only one employee. Someone told you to remove that employee also. Once you remove that employee, obviously the biggest problem is along with that employee, the department details will also get deleted. But who told you to delete the department? Department is not being deleted. Only employee has resigned. The only employee in the department also resigned. So right now the department is not having any employees. It doesn't mean that the department is closed. Department is active, but right now there are no employees working for the department. In this particular case, when you try to delete the last employee of a department along with the department employee details, the department details will also get deleted, because the department details are also stored in the same table. If at least there are two employees, if you delete one employee, at least the other employee will maintain the department details. If he is the last employee, obviously once you delete the employee, the department details also are going to get deleted. This is called the deletion anomaly. So you need to take care of all these things. And one more thing is modification anomaly. These are all things that are going to come under update anomalies: insertion of new tuples, deletion of an existing tuple, or modifying a particular tuple. Now, someone wants to, there is a change in the department numbers in the organization. Previously, the research department was given, maybe you can just take an example. For example, there is a change in the manager of department 5. This is a meaningful example. So previously there was a manager by the name Kiran who is leading the department number 5. But that person has resigned. Now a new manager has come. But already in your particular table, for all the employees working in that particular department, the manager SSN is of Kiran only. But right now, a new manager has come. Is it not your responsibility to update the manager social security number for all the employees working for the department number 5? Yes. If that is the case, is it that you have to update in one tuple or in all the tuples belonging to department number 5? Yes, if there are 30 employees working for the department 5, you have to modify all the 30 tuples manager social security number. This is one more anomaly when you try modifying the value of the tuples. So these are the problems which are going to encounter when you try updating your database. We call them as update anomalies. So we need to eliminate redundancy, and also we have to avoid update anomalies. So finally, to conclude the second informal guideline, the guideline says like this. What it says: design the database relation schema so that no insertion, deletion or modification anomalies are present in the relation. If any such anomalies are present, you have to ensure that the programs that update the database will operate correctly. So always this is a burden for the programmer who is going to deal with these kind of anomalies. So try to avoid or eliminate these kind of anomalies. We call them as update anomalies, insertion, deletion, and one more modification anomalies. So this is your design guideline 2. So the example is, you can take these examples in the employee department. If a particular manager is going to resign and a new manager is going to come in for the department, who are all the employees that are added? For every employee, the manager SSN has to be updated. This is called modification anomaly. So like this, you can take up one example for each kind of anomaly and explain this particular guideline. Now the third guideline which you have to understand is null values. Null values are always going to become a problem for us. And there are different interpretations for null value. Why people will add null values in the database? Why intentionally we put null values? There are several analogies on this. You need to understand multiple interpretations with respect to null values. Let us see certain bullets that are being displayed here. If you just see these bullets, the first point which we would like to explain here is the attributes does not apply to a particular tuple will always be null. For example, we have taken up in the class visa status. Visa is required for only NRI students. That means international students. If an international student is going to come and join in our university, and his visa number should be maintained because he should have a valid visa. Then only is permitted to come and study in the particular university. Suppose if along with him, even local students will also be studying in the university. For local students, will there be any visa number? Visa number will only be there for international students. But if you have an attribute called visa status in your particular table called student, then what value you give for local students? For local students, the only possibility is you have to give null value. For local students, you have to give null value. This is one place where we'll be encountering null values. The second context where we encounter null values, you can just check here. You can just check here. When you have a tuple where an attribute value is not known, for example, date of birth of an employee. Right now, the employee has not produced any valid date of birth certificate. So we are going to keep his date of birth as null temporarily. This is a possibility of getting a null value. And next one, the value is unknown. The value is known but absent. So the value is known to you, but right now the value is absent. That means you cannot say that the value is not there. We have not recorded it yet. For example, home phone number. Home phone number is not a mandatory attribute. So a person may or may not add a home phone number. He may be having a home phone number, but he may not provide you, or you have not recorded the home phone number of the employee. So you need to keep it null. So there are different contexts where we are going to add null values for the attributes. But what this particular informal guideline suggests you is to avoid as much as possible null values. So that particular guideline you can see here. As far as possible, avoid placing attributes in a base relation whose values may frequently be null. So try to avoid null values in your base relation. What is base relation? In your master table. In your master table, try to have complete details for all the tuples, for all the attributes of each and every tuple, try to have a value. So this is the third guideline. And now we move on to the fourth guideline, where we are going to check for spurious tuples. Is there any possibility of getting unwanted tuples added to your table? Have you identified them? If you have identified them, try to identify the root cause why these unwanted tuples are coming in your table. So this workout you have to make. For example, take two relations. So employee location is one relation and employee project one is another location. If you look into these particular two relations, in employee location, we have got only two attributes. What are the two attributes? Employee name and project location. A combination of the employee name and the project location together will form the primary key, because here we don't have employee social security number, or you don't have the project what do you call department number which is going to head that particular project. These two attributes what we have, employee name and project location, individually they are not key attributes, but together they can form your primary key. Similarly, for employee project one relationship, we have got certain attributes where you have got for an employee we are having on which project number is working and for how many hours he is going to work on that project and what is the project name and project location. Suppose if the employee is working on 3 projects, there will be 3 entries for the same social security number where the project number is going to change and the number of hours is going to change, and definitely obviously project name and project location are going to change. But what can repeat here is the social security number, for because an employee can work on multiple projects. But a combination of social security, that is the reason why social security number is not taken as a primary key. You can ask me, sir, SSN is there, why you have not taken it as a primary key? We cannot take SSN as the primary key because just now I told you one employee can work on multiple projects. If one employee is working on multiple projects, definitely the employee social security number should repeat. But a combination of social security number and the project number together will be unique. That means an employee working on a particular project number, and there will be only one entry for each project for that particular employee. So that's why a combination of social security number and project number are considered together as the primary key. So this is the explanation that is given for these particular two relations. You don't require them. I already have explained it. Now, someone has performed a natural join on this particular what you call employee project one and employee location. So after performing the join operation, you can see here a combined table which is having the tuples of both the relations. So social security number, project number, hours, project name, project location, and employee name. All these things are being added. If we just get into this particular relationships, can you tell me what is the common attribute in these two relations? Because if you want to perform a natural join operation, there should be a common field. What is the common attribute? Is the employee name common? No. Is the social security number common? No. What is common? Project location. So project location is the only possibility. But is project location a key attribute alone? No. Project location is not alone a key attribute, but we have no other go. If someone asks you to join these two tables, you need to identify a common attribute called project location and joining. Okay. If you perform join, the tuples will be joined based on the project location. Unfortunately, you will end up with some problem. That is called spurious tuples. Spurious tuples are the tuples which are identified by using asterisk. If you see the diagram here, certain tuples are being identified with one star here. You see, these are the tuples which we don't want. Why we don't want? Because unfortunately, as we have joined both the tables using project location, so there are certain employees who will be working on different projects, and there is a possibility that the employees working on the same project will have duplicates here. For example, you can see the project location, Bel Air. So who is working on that? Smith. And who is the other person working on that? English. So they both are working on product X only. And but they're working for 32.5 hours because they are working on the same project number remains the same, but social security number is repeated here. The social security is repeated here. That is the spurious tuple. It is not supposed to be for English Joycey. The social security number should not be this. That should be a different number. But here the join operation has failed. Why the join operation has failed? Because the join operation is not happening on the social security number. The join operation is happening on the project location. As the project location is matching, simply it is adding the social security number. But this social security number is not going to belong to Joyce. You can take like that any examples where you will have spurious tuples. Smith is having this social security number, that is perfect. But when it comes to Joyce, we have got a different social security number which is not of him. This is called as spurious tuple. This problem has occurred very clearly here. We can understand this problem has occurred because the join operation is happening on project location, which is not a key attribute. As project location is not a key attribute, the biggest problem has come where spurious tuples are going to get added to your table. This is the important observation we have to make, and we have to avoid this particular problem. So what is the last design guideline? Finally, the last design guideline goes like this. Avoid relations that contain matching attributes that are not foreign key primary key combinations. Avoid relations that contain matching attributes that are not foreign key primary key combinations. But unfortunately, this we have not taken care. What are the common attribute that we have matching attribute we have taken is project location. Project location is neither a primary key nor a foreign key. It is an ordinary attribute. Using that attribute, you have tried joining two tables and you have landed up with unwanted tuples or spurious tuples. This is the fourth design guideline, and I have given here a summary of all the informal design guidelines. All the four guidelines definitions we have put in this table. This is for only for your reference. These are the four guidelines. In the examination, if this question is asked, you have to write the guideline and you have to give an example like this where that problem is going to come. Now we move on to, with this informal knowledge and informal design guidelines, let us move on to an important topic called functional dependencies, which is the heart for this particular chapter. The entire chapter depends on this concept called functional dependency. What is functional dependency? There will be definition. Definition will always be there, which is theoretical and which is exactly to be written in your examination for getting your marks. But understanding the underlying meaning of the definition is very, very important. How far you have understood the definition, how far you could implement that particular definition for a practical scenario is very, very important. So basically, dependency is nothing but one component depending on another component. So once there is a dependency, there is a constraint. I'm depending on something means there is a constraint. So there is a condition. For anything I want to do, there is a dependency on some other entity. So without an interaction with the other entity, I cannot take any decision. So this is called a fundamental dependency between any two components. So here in functional dependency concept, we will try to identify components in a particular relation. You can ask me, sir, what are components in a relation? Basically, a relation is a table. Every relation will have a set of attributes. For example, we have got n attributes in a relation A1 to AN. So the entire database, assume that the entire database is having these n attributes. I'm not talking about one table. I'm talking about the entire database. For example, you have got company database. In company database, you have got n number of tables. Each table is having so many attributes. All together in the entire database, how many attributes are there? Let us assume that there are n attributes. And in these n attributes are being grouped to form one set, and we call it as a universal relational schema. So usually we have a schema separately for each and every table. For the entire database, we have got database relational schema. It is nothing but a single universal relation schema. Here it is going to have the attributes of all the tables together. So let us start with this. We have got one universal relational schema R with all possible attributes in the database. Now, what exactly is functional dependency? Definition wise, let us first see, then we will understand it with practical example. Once I take up the practical example, you will understand this. Before getting into the practical example, let me quickly tell you what is the definition. A functional dependency is always denoted by this notation. You can see X tends to Y, or maybe you can say X to Y. Just a moment. Someone, Snehil Anand. Snehil Anand is your classmate, right? Who is he? Snehilanand. Who is he? Snehilanand. Somebody should respond.
B section student, sir.
Everybody. Right. If you just look into this particular definition, basically a functional dependency is represented by this notation x to y. So you can ask me what is x and what is y. We have got one universal relational schema with n attributes. Out of these attributes, I will group certain attributes and I call it as a component. So for this particular set, x is one subset and y is another subset. X is a component which is made up of attributes which are subset of this relation schema R. Similarly, y is also holding some attributes which are belonging to the same relation. That means in the same database relation, we are going to identify two components, x and y, where x is a set of certain attributes and y is another set of attributes, then we will try to generate a dependency from one component to other component. To read this, you have to say that y is functionally depending on x. That means the attribute values in y, in the component y, what are the attributes are there? Those attribute values, they depend on the attribute values of the component x. That means y is functionally depending on x. You have to read it in reverse direction. Y is functionally depending upon x. So we have got two sets of attributes, x and y. So if you want to say that y is functionally depending on x, then this particular condition should be satisfied. You need to consider two tuples. What are the two tuples? T1 and T2. Let me take two tuples from the set x. So if these two tuples in the set x have the same value for that particular attributes, then definitely the same tuples in the set y should also have the same value. Let me explain this concept. This much is the idea you need to understand. This is what you are expected to understand. To understand this phrase, let me take you to one example. I'll take you to one example. Take the employee project relation, which we have already considered. In employee project relationship, we are telling that the employee name is functionally dependent on the social security number. Will you agree? Will you agree that an employee name depends on the social security number? Yes, definitely. To uniquely identify an employee, what is the primary key? Social security number. We depend on the social security number to identify an employee name, because in a particular organization, two employees can have the same name, but still we will be able to assign a value for the name of the employee based on his social security number. So employee name is an attribute which functionally depends upon the value of the social security number. But if you see here, this social security number is a unique value. It is a primary key. It is a primary key. So that is very important. Basically, you have to understand that a depending attribute will always be derived from one base attribute, which basically will be a primary key. Let us take one more example. If you have with you the project number, you can identify a unique combination of project name and project location. A unique combination of project name and project location is only possible if you have a project number with you. If you do not have a project number, people will ask you, you are asking about the project name and project location, but unfortunately, certain two projects are being located in the same place. Two projects are located in the same place, but still I will be able to identify those projects, and there's a possibility that both the project names are being given the same name. You cannot say that two project names should be the same and their project location should not be the same. I say that project X location Tumkur, project Y location Tumkur, no ambiguity. But if I say project X location Tumkur, again project X location Tumkur, then to uniquely identify that particular combination, you will ask me, are these two projects one and the same or are they different? If you want to say that both the projects are one and the same, definitely they should have a common project number. So ultimately, you depend on the project number to clarify this particular doubt. So once I have two projects with the same project name and project location, people will definitely ask you, how come two projects will have same name and project location? Then I have to say that it is a duplication. Basically, both the projects names, what I'm going to suggest, they are one and the same because they share the common project number. So similarly, you can say that for if there are two project numbers, if there are two entries for the same project number, definitely their project name and project location should also be the same. That means the project name and project location totally depends on the attribute called project number. So this particular set of attributes is functionally depending on a base attribute called project number. And you can see one more example. Here there is a new attribute called number of hours. This new attribute called number of hours is being derived from a combination of two base attributes. What are the base attributes? Social security number and project number. If you remember, there is employee table, there is project table. How you relate employee table with the project table? Every employee may work on one or more projects. So where the projects on which he is working will have a unique project number. So when a particular employee is currently related to a project, you need to engage some time with that project. He has to spend some time on that project. So the number of hours for which an employee is going to work on a project, that can only be derived or that can only be defined if you have the values for this particular combination. Now, one question I'll ask you. Suppose there is an employee with the social security number 1 and the project number is AB, project number is X. So employee 1 working on project number X. Definitely the number of hours is fixed. Wherever you have a combination of the same employee with the same project number, definitely the number of hours should also be the same. There is no question of having different hours for the same person working on the same project, because if a person is working on a project, the number of hours is fixed for that project. Even you have multiple tuples for these particular attributes and assume that all the tuples will have the same values, same employee, same project number, ensure that you will also have same hours, because hours is functionally depending on this particular combination of attributes. So ultimately from these examples, you have to understand that the attributes on the right hand side, they are functionally depending on the attributes on the left hand side. That means here in this example, there is only one attribute on the left hand side and right hand side. But here on the right hand side, we have got set of attributes. In this case, on the left hand side, we have got set of attributes. That means I can have a set of attributes on the left hand side as well as a set of attributes on the right hand side. So functional dependency always happens between two sets of attributes. Now, let us take one more practical example with values to understand what are legal functional dependencies and what are not functional dependencies. So what are that I have highlighted in bold face here? These are all valid functional dependencies. Let me explain you why they are valid. I am telling that C is functionally depending on B. Please listen carefully. I am telling that C is functionally depending on B. That means what you have to understand. Please, all of you go through these particular two columns B and C. In B and C, I'm telling that C is functionally depending on B. For a unique value of B, there should be the same value for C. Let us see whether it is happening or not. So you see here, for B1, what is the value for C? C1. For B2, C2. Again, B2 is coming. Definitely, the value for C is C2 only. That means as C is functionally depending on B, for a unique value of B, there should be a unique value for C also. For example, B2, C2. Again, if you repeat the same tuple with the same value for B2, then definitely in the column C also you should have the same value. For example, just now I told you, social security number, project number. Again, the same social security number, same project number you are writing means the project number is functionally dependent on the social security number. That insists that one employee should only work on one project. If the employee social security is coming, definitely the same project number is supposed to come. So because you are going to have a functional dependency between those two. But in practice, we say that one employee can work on any number of projects, where if in that case there is no functional dependency, because one employee can work on multiple projects. So social security number column will be the same, but the project number keeps on changing. There you cannot say they are functionally dependent. So this is one example where you can see that B2, C2, B2, C2 is repeated twice. The values are one and the same. So the value of C depends on the value of B. Here, when I want to give value for this C column, I have to look the value for B column. For the C, what was the value for B? B2. For C2, it is B2. Here also for C2, it should be B2 only. Now we'll see the second relationship. Is B functionally depending on C? Is B functionally depending on C? That means the value of B depends on the value of C. Let us read it in the reverse direction. C1, B1. For C1, what is the combination? B1. For C2, B2. Again, C2 is coming. So definitely it should be B2. So B2 should have the same value. C2, B2. Here also C2, B2. Because there is a functional dependency. And for C4, B3. For C1 and C4, you don't need to worry because there is only one entry for C1 and C4. But here you can check whether functional dependency is existing or not by taking the values of C2. The value of C2 depends on B2. So wherever there is C2, it depends on B2 only. You cannot write here B1 or B3. It should be B2 only. And now we'll see one more example like this, the last one, not everything. You can check yourself later. B is functionally depending on combination of C and D. Let us see whether this is happening or not. I'm telling that B is functionally depending on the values of C and D. Let us go with the values of B and C and D. So you take B1. For B1, B1 is functionally depending upon C1 and D1. Then B2. B2 is functionally depending on C2 and D2. And B2 is functionally depending upon C2 and D3. If you see here, the value of B2 is functionally depending upon both C and D. Both C and D. That means what the values of C as well as the value of D. So this is the way you have to understand how this functional dependency is going to work. And these are some examples where there is violation. I'll only explain one violation. For example, A to B. Nothing but B depends on A. But if I say B depends on A, for all values of B, you check B1, A1, B2, A1, and B2, A2. If you see here, the value of B2, B2, what you are considering should depend for the first entry you check, you are telling that B2 depends on A1. In the next line only, you are telling that B2 depends on A2. How it is possible? It is a violation. If you are writing here B2, you should have also written here A1. But there is no functional dependency because for the same value of B, nothing but B2, you have different values for A. Then how can you say that B is functionally depending on A? Definitely B is not functionally depending on A. We'll take one more example. C is functionally dependent on D. See the column C. You see one by one. C and D, right? C1, D1. C2, D2. No issue. Again, C2 is coming. Definitely it should be D2. But here what has come? D3. That means you are telling that C2 depends on D2 here and C2 depends on D3 in the next tuple. It is a violation because we have given in the definition for two tuples of X, if they have same values, they should also have same values in the set Y. If Y is functionally depending on X, any two tuples sharing same value of X should also share same value of Y. That is called functional dependency. That is being violated here. Here, if you just see this example, D to C, you just can just check D1, C1, D2, C2, again D3, C2. That means the C2, C is not functionally depending on D. For a common value of C, we have different values for D. That means C is not functionally dependent on D. This way you have to identify what are functional dependencies and what are not. Here these are violations. You cannot claim them as functional dependencies. So these are and all what are being written in boldface. You can claim that they are all functional dependencies. So functional dependency is fundamentally a dependency from one set of attributes to another set of attributes, where the attributes of set 1 and attributes of set 2 are fundamentally the subset of the attributes of the universal set. That is the simple idea here. So we can just see a diagrammatic notation for the functional dependency. If you see in this particular schematic diagram, you see here we start from social security number. Social security number is the attribute on which these attributes are functionally dependent. What are the other attributes that are functionally dependent on social security number? Employee name, birth date, address. All these things should depend on the social security number. For a given social security number, you have the same, for a given social security number, you have a unique combination of name, birth date, and address. So I can say that these attributes, these three attributes, employee name, birth date, and address, are functionally depending on SSN. And the other case you see, department number is the base attribute, which is the primary key of the department table. So the department name as well as the manager SSN, they all depending upon the department. For a particular department, there will be a unique combination of name of the department and the manager social security number. This is fixed. So this combination is fixed for a given department. So department name and department manager SSN, these two attributes, the set of these two attributes are functionally depending on the attribute called D number. You can see here, arrowhead always points to depending attributes, and arrow tail starts here. It shows that what is the base attribute from on which the other attributes are functionally dependent. Now, can you identify in employee project relation what are the functional dependencies? You can just see here the project name and project location, a combination of these two attributes. This set of attributes is functionally depending upon the project number. Similarly, you can understand here the employee name is functionally depending upon the social security number. For a social security number, if someone asks you, give the student name, the first and foremost question you ask is, first you give me the USN. If you give the USN, I will give the name of the student. Who is university seat number 23? Then some student name will come. So university seat number is the basis for me to define a name for the student. So here, the name of that particular employee is functionally depending upon the social security number. And similarly, the number of hours for which a person is going to work always depends on two attributes. You see here, hours is functionally depending upon a combination of social security number and project number. A particular employee working on a particular project will decide how many hours he is working on that. So hours is an attribute which is functionally depending upon this set of attributes called SSN and P number. A combination of these two will be used to define the number of hours. This is called functional dependency. They always the arrowhead will point to the depending attribute. Depending attribute. So hours depends on SSN and P number. This way you have to understand the concept of functional dependency. Now, once we have got a preliminary idea on functional dependency, let us see certain inference rules that are used for functional dependencies. So before getting into the inference rule, let me take one example. Before getting into actual inference rules, let us take some examples. Every department will have one manager. We have to agree for that. No department will have multiple managers. So the number of the manager for a department is unique and it is single. The participation will be single. One manager, one of the employees of the department will participate in the relation in the role of a manager. So the department number uniquely determines the manager's social security number. If someone gives you the department number, you can easily tell what is the manager's social security number. That means the manager's social security number is functionally depending upon the department in which he is working. So you can see the functional dependency. Manager SSN is functionally depending upon the department number. Similarly, a manager has a unique phone number called manager phone number. Whenever you give the manager social security number, you have always an option of retrieving his phone number. So a unique phone number will be added to the manager of the department. So no two department managers will have the same phone number. That is why I am telling that it is a unique phone number attached to a manager. So the manager phone number is functionally depending upon the manager's social security number. Now, my question is, once I have two functional dependencies like this, manager SSN functionally depending upon the department number, and manager phone number functionally depending upon manager SSN. Can't I use a transitive property here? You see here, department number to manager social security number, manager social security number to manager phone number. Can't I use transitive property and say that the manager phone number is functionally depending upon the department number? Yes. By applying transitive property, I can say that manager phone number is functionally depending on the department number. In between who comes is the manager social security number. So this is a new functional dependency that we have obtained by applying a property called transitive property. So like this, there are several inference rules. We call them as properties or inference rules. They are going to help us in defining the functional dependencies. Now, one important definition we need to understand. Please go through this line definition. The set of all dependencies that include F as well as all dependencies that can be inferred from F is called the closure of F. That means you have to understand like this. If you are given with one set of functional dependencies, andre illi for example nodi illi ನಿಮ್ಮ company database alli you can just check here. I'll go back. How many functional dependencies you have defined here? A, B, C. So all these three functional dependencies, I'll put in one set and I call it as set of functional dependencies, and I give a name for it called F. What is F? F is a set of functional dependencies. How many functional dependencies are there? Three functional dependencies are there. Three functional dependencies are there. These three together grouped under one set, and we call it as the functional dependency set. And if we have such kind of functional dependency set, and some of your friend wants to infer or create new functional dependencies from the existing set of functional dependencies. So I can create new functional dependencies from the existing set of functional dependencies. That new functional dependencies which are created from the existing functional dependencies together, both, that means the existing functional dependencies as well as the newly generated functional dependencies put together, we call it as the closure. That is identified by the notation called F plus. Wherever you have, wherever you find a notation called F plus, you have to understand this is going to is a closure of F. What is closure of F? Closure of F is nothing but all the functional dependencies that are there in F as well as all dependencies that can be inferred from F. That means what are the new functional dependencies that can be inferred, that plus the original functional dependencies put together, we call it as closure of F. The closure of F is symbolically represented as F plus. Now, let us take one set of functional dependencies. ನಾನು ಆವಾಗಲೇ ತೋರಿಸಿದ್ನಲ್ಲ, there are certain functional dependencies. We can group them and make them as a set and call it as set of functional dependencies. If you just observe this particular functional dependency set, how many functional dependencies are there? This is one functional dependency where employee name, birth date, address and D number, this set of attributes, they depend upon SSN. Similarly, one more functional dependency, the department name as well as the manager social security number purely depends on the department number. This is one more functional dependency. This functional dependency as well as this functional dependency together is called as the functional dependency set F. From this functional dependency set F, we are going to infer new functional dependencies like this, for example. So what is your closure of F? Closure of F is nothing but these existing functional dependencies plus the newly inferred functional dependencies. As a whole, we call it as closure of F. This is the way you have to understand what is closure of a particular functional dependency set F. Now, we will see certain inference rules. After going through these rules, let us wind up the class. Tomorrow we'll continue. Let me quickly tell you what are these inference rules. Basically, before going through these inference rules, but let us see the notation to denote functional dependency. So till now we are telling that there is one functional dependency. Assume that y is depending on x. This is one known functional dependency. It is already existing. From this known functional dependency, I want to infer a new functional dependency. That new set of functional dependencies which are going to infer from the existing will be represented by this. You can see this notation. Wherever you find this notation, you have to interpret like this: x to y. This functional dependency infers a set of functional dependencies called f. So f is a set of functional dependencies which is inferred from that this particular this x to y is being inferred from the set of functional dependencies f. That means this is a new functional dependency that you are going to infer from an existing set of functional dependency. So already we have got one existing set of functional dependencies called f. From this particular set, we are going to infer a new functional dependency called x to y. So this is the notation wherever you find that this is an inferred functional dependency from f. You have to read it like this: x to y is an inferred functional dependency from the existing functional dependency set f. This is the notation you have to use. Now, there are several inference rules. Now I am going to list some 6 inference rules. Out of these 6 inference rules, 3 are very important. They are the base inference rules. We also call them as Armstrong axioms. In the examination, if it is asked, what are Armstrong's axioms? List the Armstrong's axioms and prove them. So for every inference, what I'm going to see here, there is a proof. I will go through that proof also. You will easily understand what that proof is. But in the examination, it can be asked, what are Armstrong's axioms, and prove them. Or the other way, what are inference rules? List and prove. So if they ask you what are inference rules and ask you to list and prove, you have to write all the 6 inference rules. Suppose if they ask you what are Armstrong's axioms, then only you have to write the first 3, because the first 3 are only called as Armstrong's axioms. The next 3 rules which you are going to see, they are going to get derived from these. They're all derived rules. If you have these 3 basic rules, you can derive the next 3. That's why they are called derived rules. And these are the basic rules, or the base rules. These 3 base rules are called as Armstrong's axioms, or they are also called as basic inference rules. What is the first inference rule? Reflexive property, reflexive rule. Second one is augmentation rule. Third one is transitivity rule. Already I have explained one example where transitivity is being taken in functional dependency. Let us see what is this reflexive rule. The first and foremost important thing when you talk about reflexive rule is subset concept. If you want to say that y is functionally depending on x, make sure that y is a subset of x. That means the attribute y, what you are going to consider, or a set of attributes which you are going to consider as y, should be a subset of the set of attributes x. Then only you can say that y is functionally depending upon x. This is first rule called reflexive rule. If a set y is a subset of the set x, then y is functionally depending on x. That is common sense. What is this augmentation rule? Assume that already you have got one functional dependency called y depending on x. If you know that y is depending on x, augmenting a new set on both left hand and right hand side will retain the same dependency. See here, I have got a functional dependency x to y. And once I have this, I can infer a new functional dependency xz to yz. That means by augmenting an additional set on either sides will not affect the functional dependency. The functional dependency will retain. If y is functionally depending on x, then definitely yz is going to be functionally depending on xz. If you see here on the left hand side and right hand side, you have augmented a new set called z that is not going to remove this functional dependency. The existing functional dependency will be preserved. This is called augmentation rule. The third rule is called the transitivity rule. What is this transitivity? If a to b, b to c, then a to c. That you know from childhood. What is the transitive rule? So if you just see that if y is depending on x and in turn z is depending on y, I can claim that z depends on x. This is as simple as your simple transitivity rule. Here y depends on x. in turn Z depends on Y, then definitely Z depends on X. That's why I've written Z depends on X. These are the three basic Armstrong axioms, are the first basic inference rules. If you see these inference rules, for every inference rule, there is a proof given in your book. You can easily understand these particular proofs. For example, what is first inference rule? It is, if you say want to say that one set has to be functionally dependent on other set, then the functionally dependent set should be a subset of the other. That is as simple as this. For example, suppose that Y is a subset of X. Then take any two tuples T1 and T2. Any two tuples that exist in some relations instance of R of us, if we have a value of, if in the set X, if we have the same value for the attributes in two tuples, then definitely they should have the same values in the set Y also, because Y is a subset of X. I'll tell you like one example like this. There are two attributes A and B, and an attribute called B depends on this. AB is one combination. The other side there is one more attribute called B. Definitely B is a subset of A and B. B is a subset of A and B. Suppose if I say that there are two tuples with the same value of B in set 1, definitely in the set 2 also B should have the same value, because you know that B is a subset of the superset A and B only. So this is a simple common sense where you can what do you call, prove this particular inference rule. This is a simple rule. And second proof is being done by contradiction. What is contradiction? Whatever the inference rule that is there, we say that we start with that it is false, it is not going to be there, and finally we will prove that our assumption is wrong. This is called contradiction. We start with the wrong assumption and finally say that our assumption is wrong at the end. Whatever the assumption we have started with is wrong at the end. That means the original thing is correct. This contradiction you can easily understand here. I just recommend you to go through these particular statements at your, after the class to understand this proof. So here there are sub conditions that you have to understand. So you can just see there are two tuples T1 and T2, and if you want to have this functional dependency Y depending on X to hold good, then we have to prove that XZ to YZ also. What is second inference rule? Augmentation. So if you want to augment a new set on either sides, the functional dependency should hold good. But we assume that after adding a new set on either sides, we start with the assumption that the functional dependency is not going to hold good. How we are going to say that? We say that this functional dependency fails if you augment Z on both the sides. If you augment Z on the both sides, we start with an assumption that the functional dependency will not hold good. That is being proven wrong with these particular conditions. So take two tuples T1 and T2 in that relation. So assume that in the set X, there are two tuples with the same value for the attributes of X. Then in set Y also, the two tuples are having the same value. So once I say these two, I can say that Y is functionally depending on X, because the tuples share the same value, share the same value in both set X and set Y. So I can say that Y is functionally depending on X. This is known to us because we have started with our existing functional dependency that Y depends on X. So this is straightforward. Then we say that we augment Z to X. Once you add a new set Z to the existing set X, then we have found that the same tuples that are considering are having the same values for a combination of X and Z in both the tuples. So this is fine. But the fourth point, you have to carefully go through it. Here we are telling that for the two tuples under consideration, even though they are sharing the same value for the attribute combination XZ, unfortunately, they are not having the same values for the same tuples for attribute combination YZ. On the left hand side, we have got XZ. There the tuples share the same value, but on the right hand side we have got the set yz where the same tuples they have different values. Why we have taken this fourth point means we only started that the functional dependency yz depending on xz is not going to hold. That means as this functional dependency is not there, the yz combination can be different from xz combination. That is the reason why here we have taken like this. After taking this, we have finally deduced, like this. This is not possible to say, is claiming why it is not possible to say, because from 1 and 3 we can deduce 5. Let us see what is 1. 1 says that t1 of x is equal to t2 of x. Then what is 3? t1 of xz is equal to t2 of xz. So from this 1 and 3, from 1 and 3 he is going to deduce the new equality called t1 of z is equal to t2 of z. Why t1 of z is equal to t2 of z? You only told that for the set x, the two tuples share the same value. Then you are telling for the set xz also it is sharing the same value. Once for x it is sharing the same value, once for xz is also it is going to share the value, definitely for z also it should share the same value. So once it shares the same value for z, this new equation has come. And now this particular equation is being deduced, and we have deduced one more equation from 2 and 5. What is 2? What is 2? 2 says that two tuples have the same values for the attribute set y. Then what is 5 says two tuples share the same value for the attribute z. That means, is it not z is functionally depending on y? Z is functionally depending on y. That means, can't I write t1 yz is equal to t2 yz? This is also possible because t1 of y is equal to t2 of y. t1 of z is also t2 of z. So I can say t1 of yz is equal to t2 of yz because as I know t1 of y is equal to t2 of y, I can argument z. I can argument z like this. Once I argument this like this particular direction, what we have got like this from 2 and 3. From 2 and 3 means from this and not 2 and 3, from 2 and 5. From 2 as well as from 5, we have got a new deduction called t1 of yz is equal to t2 of yz. But we started that yz is not functionally depending on xz. But finally we proved that yz is functionally depending on yz is functionally depending upon xz. Because if you see 6 and see third and 6, t1 of xz is equal to t2 of xz. Then see sixth one, t1 of yz is equal to t2 of yz. That means yz is functionally depending upon xz. Finally, we came to know that yz is functionally dependent on xz, but we are telling that yz functionally depending on xz does not hold good. That means it is a contradiction. Finally, you can prove that our assumption that yz functionally depending on xz is correct. So this is the proof for your inference relation 2. Like that, we have got a proof for inference relation 3 also. This we you can just go through it. Let me stop at this stage because it becomes a overload for you if you continuously bombard information from my side. So let us continue our class tomorrow. I'll tell you tomorrow's class timing after contacting with other teachers. So we'll continue from this point in tomorrow's class. Please start studying for your third test. For your third test, the portions will be your SQL part, what you have not taken in second test. And along with that SQL part, that means in the third unit, second part, I've already shared that notes that you start going through it, the types of queries, the types of operations and all. Then just have and have set go and try to solve certain new queries also, because in the examination some new relational schema may be given and you may be asked to write one query for that. The queries will go in the same line. The fundamental queries what you have studied, the same knowledge can be used to write a new query, but here you don't always expect that your company database will be asked, or maybe your orders database will be asked, or library database will be asked. There is a possibility in the examination a new database may be given for you, and you may be asked to answer certain simple queries. So try to go through the particular SQL part and try to understand all types of queries meanwhile. And in this particular fourth unit, let us see how far we are going to cover in fourth unit for your for what you call third test. What are the things that we are going to cover in all the three sections? Depending upon that, we are going to decide that portion for that third test. So right now, you keep in mind that you will have that SQL part in your third unit. Plus, in fourth unit, what are the things that will be covered? Still, we have time. Today is Wednesday, Thursday, Friday, Saturday, and again Monday are coming. We have 3-4 classes we can take so that we can cover this particular unit also. We'll tell you, let you know what will be the portion for your syllabus depending upon the progress of the syllabus. And one more request to you is, please inform your friends who have not joined today. If they have not attended today, tomorrow's class they cannot understand. I think very well you might have understood today the importance of the class. Without having a knowledge of functional dependency, without having a knowledge on the inference rules, if you say that I will understand normal forms, means definitely not possible. Normal forms totally depends on the concept called functional dependency. If you want to understand the normalization concept, please go through this functional dependency one more time and all these inference rules one more time. Then only you will understand the normalization. With this, today I am going to wind up the class. Let us meet in tomorrow's class. Meghna, 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 Meghna. Illiyappa Meghna. What about others? Let me check who are on
Sir, just
class.
left the class.
Okay, let me take the attendance for today. Don't leave the class. Don't leave the class. Let me note down your attendance. Give me 2 minutes time. Let me take screenshots. So 19CS02 is the first person. Let me put it in Word file. I'll speak to others in the next class. Those who are absent today, I'll speak to them in the next class. We need to have a record for everything. No meaning in taking classes during holidays for us. I told you very clearly in the last class only, we have got a mutual commitment. We have to work for that. Seriousness illa antandre. So 10 ವರೆಗೂ ಕಾಪಿ ಆಯ್ತು. 10 ಆದ್ಮೇಲೆ 11 to 29. ಯಾರು ಬಂದಿದಾರೋ ಅವ್ರಿಗೆಲ್ಲ ಬಂದಿದೆ. Right. Please hold on for 2 minutes, not more than that. Don't leave the class. And after 29, 31 to 45. ನೋಡಿ ಎಷ್ಟು ಜನ ಬಂದಿದ್ದಾರೆ. 31 to 45, 15 ಜನ ಬರಬೇಕು. ಎಷ್ಟು ಜನ ಇದ್ರೆ ನೋಡಿ, ನಿಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮ್ಮ ಅಟೆಂಡೆನ್ಸ್ ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ನೋಡಿದ್ರೆ. ಆದ್ಮೇಲೆ 46 to 60. Right. Okay, you can leave the meeting.
Sir, share today's 2 pages notes, sir.
ಆಯ್ತಮ್ಮ, ಏನೇನಾಗಿದೆ ಅದನ್ನಷ್ಟು ನಾನು PDF ಯಾವಾಗಲೇ ಕಳ್ಸಿಕೊಡ್ತೀನಿ, ಓದ್ಕೊಂತಾ ಇರಿ.
Okay, sir.
ಈ ಇನ್ಫರೆನ್ಸ್ ರೂಲ್ಸ್ ವರೆಗೂ ಕಳ್ಸಿಕೊಡ್ತೀನಿ, ಆಯ್ತೇನಮ್ಮ?
Okay, sir.
ಅಲ್ಲಿವರೆಗೂ ಇನ್ನ ನೆಕ್ಸ್ಟ್ 3 ರೂಲ್ಸ್ ಇದೆ, ಅದನ್ನು ಸೇರಿಸಿ ಕಳಿಸ್ತೀನಿ. ಅದನ್ನ ಓದ್ಕೊಂತಾ ಇರಿ. ಅವತ್ತು ನೀವು ಓದ್ಕೊಂತಾ ಇರಿ. ಸೊ ಪ್ರೀವಿಯಸ್ SQL ಎಲ್ಲ ಮಾಡಿ. ಅದರಲ್ಲಿ SQL ಅಲ್ಲಿ ನಿಮ್ಗೆ ಡೆಫಿನಿಷನ್ಸ್ ತರ ಬರೋದಿಲ್ಲ. ಯಾವ್ದೋ ಒಂದು ಡೇಟಾಬೇಸ್ ಕೊಟ್ಬಿಟ್ಟು ಅದಕ್ಕೆ ಕ್ವೈರಿ ಬರೆಯಕ್ಕೆ ಹೇಳ್ತಾರಲ್ವಾ, ಅದು ಅಪ್ಲಿಕೇಶನ್ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ ಅದರಲ್ಲಿ.
ಓಕೆ ಸರ್.
ಇದರಲ್ಲಿ ಇದೆಲ್ಲ ಫಂಕ್ಷನ್ ಡಿಪೆಂಡೆನ್ಸ್, ಇನ್ಫರೆನ್ಸ್ ರೂಲ್ಸ್, ಡಿಸೈನ್ ಗೈಡ್ಲೈನ್ಸ್ ಇದೆ ಅಲ್ವಾ, ಅವೆಲ್ಲಾನು ಕ್ಲಿಯರ್ ಆಗಿ ಥಿಯರಿಟಿಕಲ್ ಕ್ವಶನ್ಸ್ ಅವೆಲ್ಲ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇನ್ಫರೆನ್ಸ್ ರೂಲ್ಸ್ ಏನಿದೆ, ಆರ್ಮ್ಸ್ಟ್ರಾಂಗ್ ಆಕ್ಷನ್ಸ್ ಏನಿದೆ, ಅದ್ರ ಪ್ರೂಫ್ ಕೊಡಿ ಅಂದ್ಮೇಲೆ ನೀವು ಆಕ್ಷನ್ಸ್ ಹೇಳ್ಬೇಕು, ಈ ಪ್ರೂಫ್ ಏನ್ ಹೇಳಿದ್ವೋ ಈ ಪ್ರೂಫ್ನು ಬರೀಬೇಕಾಗುತ್ತೆ. ಏನಮ್ಮ?
ಓಕೆ ಸರ್.
ನಾನು ಶೇರ್ ಮಾಡ್ತೀನಿ, ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಶೇರ್ ಮಾಡ್ತೀನಿ, ಏನಾಗಿದೆ ಅಷ್ಟು
ಓಕೆ ಸರ್.
ಆಯ್ತಪ್ಪ.
ಓಕೆ.
ರೈಟ್. ನಿಮ್ ಹುಡುಗರಿಗೆ ಎಲ್ಲಾರು ಓದಕ್ಕೆ ಹೇಳಿ ಕೂತ್ಕೊಂಡು ಆಯ್ತಾ? ಕ್ಲಾಸು ಬಂದಿಲ್ಲ ಅಂತ ಓದ್ಕೊಂಡು ಕೇಳ್ರಪ್ಪ, ಅವರೆಲ್ಲ ಬುದ್ಧಿವಂತರು ಇದಾರೆ ತುಂಬಾ, ಅವ್ರು ಸ್ವಂತ ಓದ್ಕೊಳ್ಳಿ. ಅಟ್ಲೀಸ್ಟ್ ಓದ್ಕೊಂಡು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕರೆಕ್ಟ್ ಆಗಿ ಬರೆಯಕ್ಕೆ ಹೇಳಪ್ಪ, ಮಾಸ್ಟರ್ ಹೇಳಿದಾರೆ ಹಿಂಗೆ ಅಂತ ಹೇಳಪ್ಪ.
ಓಕೆ ಸರ್.
ಆಯ್ತಮ್ಮ. ರೈಟ್.